All right, hello, welcome back everybody. Good to see everyone again. So today we're going to be talking about how to improve the game feel. All right, so the objective is to use code and animation to improve the quote unquote game feel, or what people in the industry generally call juiciness, by creating player feedback. That's the most important part, in the form of either sound, color, shape, motion, and particles. These are the most common forms of feedback used to create juiciness, but it's not limited to this. The key fundamental part is just remembering that you have to give players feedback so that the immersion is created. Okay, so hopefully at this point, I'm hoping some of you will have prototypes that you've been working on up to this point, and maybe you've been playing around with it, having fun. Maybe some of you are happy with how it's been going. Probably most of you aren't, and it's not coming out the way you want, or it just doesn't quite feel right. You're not sure what isn't working. It just feels a little off. That's okay, okay? This is a natural part of the creative process. Remember, fail faster. I can't stress enough how important this lesson is in so many facets of both your creative life as well as life in general. Finding out if something doesn't work is the most fundamental process to learning and growing. So you shouldn't be afraid of failure. You should actively be striving for it as fast as you can. So don't be afraid to start over from scratch. That's what iterating is. So if you haven't started on your game, no worries. This is an excellent time to maybe think back to really what the core of what you want to make is. Try taking that brainstorming exercise sheets from week 1 and see what can I do based on a certain mechanic that I want to use. And then just play around with that. If you don't get a polished product by the end, that's not a big problem. It's better to have something that you love rather than some polished product that you don't particularly care for. So when you begin the revising and refining prospects, you should be asking yourself what's working and what isn't. And not just yourself, you should be having other people try it and tell you what's working and what isn't. Because sometimes when you're really deep in the weeds, it's really hard to be objective about your own work. So you should do this while all your stuff is very rough. Maybe you haven't done any final animations yet. You haven't incorporated your walk cycles other than just a very preliminary couple frames. And that's good. You don't want to overcommit during the prototype phase because your time is important. So before you start finalizing your final animations, think about what the most important mechanic is, because that's what you're going to want to prioritize first, right? In Super Mario, Miyamoto spent months just perfecting the jump mechanic to make sure it felt just right. With Sonic, it's all about the running and the feeling of going fast. So think about what your game is going to be about, and what is probably the most important mechanical element towards that. And that's what you want to focus on first to make sure you make the best use of your time, because not all mechanics are equally important. So use that as a launching off point. And once you're happy with the direction of your game, then you can start working on actually improving the game feel. This is where things start really getting satisfying from the play testing point of view. And that's what we're going to be talking about today. So the tools I'll be using today is Unity Engine. Some of you may be familiar with Unity. Some others may be using Godot or Scratch. Use whatever editing and development environment is most comfortable for you. But Unity Engine is what I'm going to be using today, and you'll be able to get equivalent effects in pretty much any other engine as well. In addition to this, we'll be doing a bit of coding today. So if you're not a coder, please don't be intimidated. A lot of creatives these days, a lot of the most interesting art is being created by people in cross disciplines with the sciences as well as the humanities. So maybe this is an opportunity to sort of get a little less intimidated by code, sort of get familiar with how it looks. And then some of you I know are probably in computer science classes right now as we speak. So even if you're not particularly familiar with the syntax of C#, which is what we'll be using today, it should all make general sense, and you should be able to take the principles and apply to whatever language you're using or development environment you are using. Okay. So why don't we dive right into it then? Let me show you a simple little game that I've started building here. It's a simple environment. If you look, there is just 2 walls, a floor, and then a player that can be controlled using a basic movement script that I wrote beforehand that lets you move around and jump. That's about it. And you can see the code here. It's fairly, it might look a little intimidating, but it's actually pretty straightforward. This section right here, what happens in update, shows you pretty much happens every frame, and it just tells, we have it checked to see if any inputs are being done. So it checks for the input of whether you're pressing left or right for the horizontal axis, as well as checking whether you press jump. And then if you do any of these things, then it applies velocity to the rigid body, which is something that's part of Unity, might not be part of the development environment that you use. But that's about it. It's fairly straightforward. And you don't have to write your own movement script from scratch. There are plenty of assets and scripts that people have written that you can just totally take and use for yourself. It's very common. You can go to, for example, the Unity Assets Store, which is integrated right into here. And then you can go and then download some free movement scripts and things like that. If you're primarily a designer and you're not a developer, that's totally fine. So don't feel like the only way you can make a game is by writing all your code from scratch. It's not true. Okay, so the next thing I want to do is I'm going to create a second little character here, just so I have something interactable. I went ahead and named this enemy. I'm going to take the movement script off of this. I just duplicated the player. And so now this also has a rigid body as well as a box collider. And I'm going to go ahead and change its color just so that we can differentiate it from our player character. Why don't we make it, I don't know, green. And then we'll make our player, how about we make it yellow? There we go. All right, and yellow. So now when I compile, we have this interactable character like that. And I just saw that my character flip. I just remembered I have to lock off this character's axis. So freeze rotation along the z-axis, since we're making a 2-dimensional platformer. Okay. Excuse me. So the next thing we're going to try to do is incorporate a script so that the character can fire some sort of projectile. So I'm going to go ahead and create a new script here. And we're going to name this, oops, one more time. Create a new script. We're going to name this fire projectile. Okay. Okay, when you do that, it creates this new script and it preloads some of the text. We're going to go ahead and delete that. And we're going to first try to incorporate a basic instantiation. So that's where you create or instantiate a new object. And we want to do this when a button is pressed. Okay, so the first thing we're going to do here is check to see if the button is pressed. So void update is a function that is called every frame. So this will just constantly be happening. And what we're going to do is if input get mouse button down, and that's 0 is the left one. If this is true, then what's in these brackets will execute. And so what we're going to do is we want to create a new projectile. So I'm going to create a variable here called public game object projectile. One of the nice things about Unity is you don't have to define the variable when you declare it. You can do that later, and I'll show you. It'll show up in the inspector here, which is a nice little feature for those who've never used Unity. And what we're going to do is, for now, just put in some text here that says instantiate bullet or projectile. Okay, let's go ahead and save this. And when we come back, I'm going to now attach this fire projectile script to this player object. When I do that, you'll notice over here on the right, the script, and lo and behold, there's the projectile variable that we declared. And it has no value right now. We're going to give it one in a little bit, but we're going to leave it blank for now. So why don't we go ahead and create a projectile? Why don't we make this one look like a triangle? Okay. Let's go ahead and reset the transform. So it's over here. Okay. So you can see it's there, but it's a little large. Why don't we go ahead and shrink it down? Right around there, maybe. Looks good. And I want this to also be called projectile. And I'm going to give it a script called projectile behavior, because we have to now tell it how to behave so that when we create it, it'll work the way we want it to. So now I'm just going to go ahead and attach this projectile behavior script to the projectile object. And then I'm going to drag this whole thing into my folder called prefabs that I created so that I can make a copy of this whenever we want. So prefab is short for prefabricated. So now I can actually get rid of this object from here. And now in the projectile value, I can put this game object in there, and that's the object that's going to instantiate. So now when I go back to my codes, when I do new, I don't know, var new projectile equals instantiate, I'm going to instantiate that projectile at the exact position that my character is at. And then that's a fancy way of just saying at the same rotation that the character is at. So we're just telling it where and what rotation and what to instantiate and create. So this code is going to be different depending on what environment engine you're using and so forth. Don't focus too much on the actual test, just really focus on what we're doing. And then you can apply that to any environment later. Okay, so now this creates the projectile. Why don't we go ahead and check it to see if it works. So now when I click on the screen, it should create a projectile. And there we go. As I move around, it's creating projectiles. Nice. But those projectiles should probably be moving, right? So that's the next part we're going to do. Why don't we now go ahead and open up the projectile behavior script. Okay. So what I'm going to do here is, well, actually first, why don't we come back to fire projectile, and we want to launch it, because if we're facing a certain direction, our player object is going to have that information. So it makes more sense to actually put the force, the physics that we're applying from here. So I'm going to go ahead and do another thing here. So I'm going to launch the projectile. And I'm just going to do the code for that, which you don't need to know. You can always look this up and get references from documentation. But right now I'm just setting the velocity to a specific value, which I'm going to just make vector 2, which is times speed. And the speed is going to be a variable, which I'm going to make here, so that we can change it in the inspector rather than having to come back all the time to the script and adjust it in the script itself. So here we can see speed is now added. Let's go ahead and make it 20. And now I do this. Yep. So we got an error. If you look here, you can open up the console and it will show you what the problem is. It's missing component, right? So I forgot to attach the rigid body to the projectile. So let's go back to the prefab here, and we're going to add both a box collider 2D along with a rigid body 2D. Okay, but we don't want it falling to gravity, so we're going to go ahead and make gravity 0 for this, and make it kinematic. That's a fancy word, essentially actually just meaning that physics doesn't really apply to it. That's not quite right, but okay. Now it should work when we do this. There we go. Whoop, that's totally launching our character over. That's not really what we wanted to do. We wanted actually just to register when it touches the object. So we're actually going to turn this into a trigger. So it doesn't actually contain space anymore. It's going to pass through like it's a ghost. And it'll register when it hits another box collider, but it won't actually interact physically with it. Okay. So now if we go to the projectile, what we want to do is we want something to happen when it touches another collider. So in Unity, there's a nice event that you can access, which is on trigger enter 2D. And this function will be called every time this object's collider touches another collider. So this is called when another collider enters this collider. Okay. So what I wanted to do is if the other object it touches is an enemy, if the object it collides with is an enemy, then I want what's inside of here to trigger. And what do we want to happen? Well, first thing we want is probably to have the bullet disappear, right? So I'm going to go ahead and put destroy game object like that. This will get rid of the bullet. That way we won't have a bunch of bullets just flying off all over the place. Okay. So now we do this. When I fire, it should disappear when it touches that player, but it's not. So let's go ahead and take a look. First, why don't we see what the problem is? So I'm going to debug log and say hit. So let's see if this is even getting called. If it is, we should see that debug showing up in the console, which it's not. Meaning, most likely, yes. The problem is I haven't tagged it as enemy, which is what I was using before. So I must name it enemy. And now, voila. As it makes contact with the player or with the enemy, it disappears. Great. Okay, we'll come back to that in a little bit. But at this point, we have a semblance of a game, but it's not very satisfying, is it? We have a character that can move around, fires, but it's doesn't feel good. So what can we do in order to make this feel a little better, improve the game feel? Well, okay, first thing, an easy thing, sound. We can add sounds to make it a bit more immersive. So on the player, why don't we include a component called an audio source? And I have a couple sound effects here. I'm going to go ahead and add a laser sound. And what I want to happen is when the projectile is fired, I also want it to play a sound. So play sound effect for projectile. So first, I'm going to need to reference that audio source I added. So I'm going to add public audio source. And why don't I also reference the audio clip itself? So audio clip fire. So now what I can do is I can call that audio source. And why don't we make it about half volume. So the left side is the sound effect we're going to play, and the right side is the volume that it's going to play at. So again, the particular language or code that you're seeing here is less important than understanding the logic behind what we're doing. So this should be applicable to the different tool sets that you use in your different engines that you run. But okay, so let's go and save this. And we've declared those variables over here, but they're empty. So we got to drag this in here so that now it knows which audio source, and we're going to go and drag this sound effect there. So now we got some sound effects. All right, already an improvement. Also just play it's on awake, so I'm going to check that off. But still feels not very immersive, right? There's a lot more we can do. So after sounds, how about we include some sort of visual indicator, right? There's a lot of different senses that we work with, but three primary ones we use with gaming are sounds, sight, as well as touch, haptic feedback, which we're not going to get into today because it's a little difficult to demonstrate that here. But when your controller like vibrates and rumbles, that's haptic feedback. And that's another form of creating juiciness. Okay, so let's move on to sight. So I want some sort of visual indicator that tells me as a player that I successfully struck something. And an easy way to do that is with color. So what I want to happen now is when this enemy is struck by my projectile, I want it to change color to, let's say, just white. We'll have it flash white. Okay. Then what I need to do first is the enemy has to have some sort of reactive behavior. So I'm going to create a new script called enemy behavior. And go ahead and apply it to this enemy. And now we have the script here. Okay, so what do we want to happen? Well, it needs to happen whenever it gets hit. So this will also be based on called when hit by projectile. That's what we want to be doing. So we're going to do that with very similar, not just similar, sorry, with the identical function that we were accessing before, which is on trigger enter 2D. All right. And so when they're hit by the projectile, and we got to make sure it's the projectile. So we're going to check for that here. So if the thing that hits us is tagged as a projectile, then we want it to turn white for a specific amount of time. Okay, so how do we do that? Well, what controls the color and the visual of what we're looking at is the sprite renderer. So the enemy sprite here, you can see the color is green here. But we can change the color like this, but we want to be able to do that through the code. So the way we would write that here is well, we want multiple things actually to happen when we get hit. And so what I'm going to do is I'm going to actually create a different function for each thing. So first, what I'm going to do is I'm going to create down here a new function called void public I enumerator. You can ignore that for now. It just means it's going to be happening over a period of time. And I'm going to call this change color. All right. And I want to call that here. So I'm going to do start coroutine, change color. And so when it hits this point, it's going to go over here. So this is what happens when the coroutine starts. Okay. I'm going to leave this blank for now, but let's also think ahead of some of the other things we're going to be doing. I also wanted to create some particles later. So I'm going to say particle FX function. And we're going to create that particle FX function down here. So I'm going to create a new public void particle FX function. And then we're going to fill this in here later. And we also are going to do a screen shake. Actually, let's not get too ahead of ourselves. I'll come back to this. But okay, so let's go to change color. Well, first, why don't we save what its original color is? So I'm going to create a temporary variable here called original. And I'm going to save the color of the object. So the first thing I need to be able to do is access the color. So I'm going to go ahead and declare a sprite renderer called srend, let's say. And I'm also going to create a color variable, hit color. And then we also want to be able to decide later how long we want the color change to occur for, right? So I'm going to do floating point color duration. Okay. So when I do that, we're going to save the original color to this variable called original, and we're going to do that by accessing srend color. So this is going to get the original color that it has when this is called. And then after we save that, we're now going to change the color of srend.color to our hit color. Then I'm going to have this wait. because we want it to wait for a little bit of time before it turns back to its original color. So I'm going to do yield return, new, wait 4 seconds, color duration. Bet some of you are thinking, man, I didn't realize I was going to have to learn coding in order to make art, but that's part of the process these days. It's the 21st century. It is a very creative process, coding, I can tell you, and very fun once you get the hang of it. So I encourage all of you to give it a shot. So here is a code that returns it back to original. So here, store original color for later. Change to our desired color. Wait for the designated amount of time. And then change color back to original. Okay. So there we go. Why don't we see how this came out? So the first thing I gotta do is I gotta link the sprite renderer. So I set it there. Then we gotta decide the color that we want to change it to. We said white. And how about we make it for half a second? Okay, didn't work. And that's because the projectile has not been tagged as a projectile. So let's go ahead and do that. Yeah. And look at that. Now, get some visual feedback. It's a bit long though, isn't it? This is where playtesting comes in handy. You want to be doing this lots to get the exact amount of time that you want. So let's try 0.1 second. That's a lot better. Okay, so now we've incorporated color, a visual element. But we can go a little further than that. So why don't we actually add some special effects now, right? So in addition to just these color changes, we can actually add what are called particle systems. And particle systems can be used to create a wide range of different visual effects, from water to smoke to crowds of people to it's really only limited by your imagination. But let's go ahead and see what that looks like. So what I'm going to add here is a particle system. And look at that. So now, if you look here, it's emitting all these magenta cubes. That's not the color we want, that's not the size, but that's where the particle system controls can come really in handy. So if you look here, there's a lot of different levers and controls that you can use to really control how this particle system looks. So the first thing I'm going to do is change the color. So if we go down to renderer here, we can change the material. I'm going to go ahead and create a new material. Name it white. And then I should have just done that. No need to do that. All right. Okay, so I've changed it to white blocks now instead of magenta. Then why don't I then also decrease the size? So if we look here, you see max particle size 0.5. Why don't we lower that down? Oops. Ooh. One second. Okay, so we've decreased the lifespan of the particles, and now we also want to increase density. So I'm going to change the rate over time, like this. And it's going crazy. I'm going to also have it fade over time. So let's go back down to renderer. And I know these can be confusing. You have a lot of options with particle effects. Have fun with them. You can make an entire career out of this if you really wanted to. So let's see here. We want to change the color over lifetime, so I'm going to enable this. And we're going to bring the gradient editor, and I want it to change the alpha down to 0 over time. Okay. So still going a bit fast. We're going to change that. And now we want it to not loop. So I'm going to turn off looping. So when I play it, it'll just last for the duration. So I'm going to shorten that down to 0.3, let's say. A bit better, right? Let's maybe even bring that down to 0.1. So there we go. Not bad. Bring this up maybe to. Now we're talking, right? So now it looks like we got some impact. Okay, so now we just have to make sure that this can be played every time that the trigger happens. So let's go back to our script. And so this is our particle effects here. We want it to be called every time we're hit by a projectile. So what we're going to have to add here is another variable for particle system, because that's what we just added. We're going to call this hit smoke. Okay. And what we want is when this is called, we're going to have the hit smoke play. Easy peasy, right? So let's take a look at what that looks like. So, and all right, so we got to assign the particle system. So drag this there. Now we've got referencing that particle system. And we should also turn off play on awake. There we go. Play on awake. Okay. There we go. Not bad, huh? Really is a lot more satisfying. All right. So we've got a bit of sound, we've got about a bit of visuals, and now we can also enhance those visuals and make it actually feel like we're really looking at this. And one good way of doing that is screen shake. So by adding screen shake, you're sort of creating the illusion of making the screen your actual eyes, right? It's as though you yourself were jostled. So it gives you the illusion of having been shaken yourself and vibrated, as though you were actually in the place. So it's a very immersive, juicy mechanic that you can add. And we're going to do that here. So what I want to happen is I went ahead and wrote a shake script, which I'm just going to copy and paste for the purposes of time, but you can find similar types of scripts here. Shake screen. Actually, Let's just call it shake. Shake. Okay. And I'm just going to go ahead and copy and paste this in. And you can find different scripts that people have already made like this all over. So again, if there's something you don't know how to do, look it up. Someone's already solved the problem 9 times out of 10. And you can take their codes, either directly copy it in and you give them credits, or you can modify it for your purposes, which you're almost always going to have to do anyways to tailor make it to your particular project. Okay, so I'm going to go ahead and save this, and we're going to attach the shake to the shake script. And there are 2 functions we can call as part of it. If you look here, we can either call the minor shake or we can call the long shake. So we're going to call them sorry, 1 second. I seem to have misplaced my window. Okay, I'll just open it again. All right, so any behavior. What we want is when the enemy is hit, we want to shake the screen. So shake screen. So let's go ahead and create a function here called shake screen. Okay. What we want to do is access that camera shake script. So in order to do that, we're going to need to create a new public variable called shake, because that's the class. And we'll just call it the cam. So you want to take the cam and then do a long shake. Okay, so when we go back here, oh, and we have to set the intensity, which why don't we go ahead and set the intensity to 0.1. For this particular script, that should be about right. So come back here. We see the cam there. We're going to drag the main camera. And now you can see the whole screen shakes, right? We can even change the amounts and really make it crazy. So let's say instead of 0.1 with the intensity, I change it to 10. Well, it'll look a little disorienting, as you'll see in a second. So you want to use this judiciously. Anytime you incorporate feedback, if you make it too pronounced, it's going to interfere with the gameplay itself. So really exercise some discretion when deciding how much of any kind of feedback you want to apply. Okay, so we've got some screen shake now to add just that little extra bit of juice. We're really starting to get something that feels a lot more satisfying than we had before. So one last thing that we can add that really makes it feel like this has weight and impact is motion. So one thing we can add is a knockback effect. So let's go back to that any behavior. And I'm going to create a new function called knockback. Actually, sorry, before I do that, it actually would probably make more sense to put this code on the projectile so that whatever it hits, the projectile will be applying the force to the object. So let's take this actually to the projectile behavior. Whenever you're coding, you want to sort of think logically about where the script should be attached to, so that the actions make sense and it's scalable. So later, whenever we get maybe more players or more characters, the projectile will be the one applying the force rather than having to rewrite the same code for every character. So, okay, let's go to the projectile behavior. And what I want to do is I need to apply some force to the other characters. So first I need to check if the tag is enemy, which it is. And so then what do I need to do? I need to somehow access the other character's rigid body. So I want to, let's go and get rid of this. And we want to knock back the enemy, which in this case is Cole. Okay. So first, we need to get the direction. I'm going to do some little confusing looking code probably, but again, don't focus too much on the actual syntax. Just think about the logic. And what I'm going to do is I'm going to get the direction that the projectile is coming from based on the relative position of the projectile itself and then the thing that it's colliding with. I'm subtracting one from the other to calling that move direction. And then I'm going to get the rigid body of the thing we collided with, and then get the velocity of that. I'm just going to add, first, I wanted to lift off the ground a little so that it really gets a bit of a knockback effect. And I'm just going to do a little bit of up. This is just a default function you can call. And I'm going to multiply it by some arbitrary amounts, 5, which you can set as a variable. We're not going to do that right now. And then we also want to knock it back. So we're going to add force. You could also just do it to velocity like I did with the other one, but there's many ways to do the same thing. In this, I'm just going to do something that I already checked earlier and have a rough approximation of value. So when I do this now, get direction to knock up, and knock in the move direction. Okay. So now when I apply this, we now knock him back. Added with the screen shake, it's pretty satisfying, right? And if we wanted to sell the impact even harder, we can also, as part of the enemy behavior, add a sound effect here. So sound effect of getting hit. So why don't we add an audio source? And an audio clip. And we we want this to be hit sound. We're going to play one shot hit sound, and we'll do it at full volume, let's say. Okay. So when we come back over here, we can see now that there's an audio source here and a hit sound. So let's add an audio source. And then I'm going to grab this impact wood sound that I had prepared, add that there. Now, oh, oops, I dragged it to the wrong. There we go. Right. Yeah, we don't want it to play on the mic. All right. There we go. A lot more satisfying, right? All these bits of feedback really help sell the illusion that we are physically interacting with this virtual medium. So in addition to the motion of things like being moved around in this physical space, we also want some sort of visual feedback as to the movements that's happening. So right now we're working with these very abstract shapes, right? A square, and every time it fires, it just sort of feels like this triangle is shooting out of this very static cube. But real life isn't like that, right? In all the animation that you do, you're trying to get some sort of either literal interpretation where you animate, like say someone throwing a ball or someone jumping. You can literally do that, or you can sort of insinuate and imply motion of that nature, but in an abstracted form. So for example, if I make the cube sort of wobble, like get larger and smaller and like sort of move like jelly, that will actually sell the impression that the cube is animated with life. So I'm going to create a new script called wobble. So what do I want wobble to do? Well, it doesn't actually have to be realistic, right? Since we're not using animated sprites of people in this case, we're just going to, I want it to sort of have the impression of like maybe like a jelly, like something like jello that kind of wiggles around. And I think that would probably be plenty to sort of sell the effect of an illusion of motion, and sort of the kinesthetics of a active animated being. So I'm just going to make it simple. I'm just going to sort of push it thin first and then push it flat and then have it come back is what I'm going to do. Let's see here. Okay, so the first thing I'm going to do is I'm going to need to access the sprite. So I'm also going to need to be able to tell it how intense I want the wiggling to be. So I'm going to have a float called intensity. And then I also want to be able to decide how fast and for how long that wiggle is going to occur. So I'm going to create another one called speed. Okay. Then I'm going to want to define, oops, sorry about that. Then I'm going to want to define what the size is going to be when it's tall and the size is going to be when it's wide. And these are known in as variables called vector 2s. If you work in 3 dimensions, it'd be vector 3s. But okay, so I'm going to create one for the starting scale. This is the size that it starts at. I'm going to create one for the tall. And then I'm going to create one for the wide. Okay, So I've declared my variables, and now I have to actually give them a value. So what I'm going to do is when this wakes up, so this function gets called once when the object wakes up. So as soon as it wakes up, I'm going to just apply these variables here to this. And so what I'm going to do is I'm going to take the starting scale and make it equal 1 to 1, since the object should be just a 100% in all dimensions object. Then I'm going to make the tall one equal 1f minus intensity. So this is the x-axis, so it's going to be 1f minus the intensity that we defined. And then for the y-axis, I'm going to have it be 1f plus intensity. That way, the total volume of our shape stays the same. If you'll remember from the last workshop number 2, when we're doing the walk cycle animation, anytime you change the shape of an object, you want the volumetric, the volume of the object to stay the same. Otherwise, it'll look like it's either shrinking or growing larger in an arbitrary manner, which doesn't look natural. So, okay, then we're going to go wide. And then we're going to reverse it, plus intensity. And then 1f minus intensity. Okay. So we got all our variables sorted out at the beginning. Now, I want this to be callable by other functions. So I'm going to make it a public function called start wobble. Oops, wobble. Which I want it actually to start a coroutine. I don't want to have to write this out in the other function, so I'm just going to do this extra step, which might seem silly, but makes my life easier. All right, and then here, this is the coroutine wobble. All right, so what I'm going to do is a process called lerping, and it's a little complicated and a bit mathematical. So I'm going to go ahead and skip that and add the codes as it is so that we can see the end product. And when we apply it, and we call it whenever okay. We are at time. I apologize. So I am going to do this real demonstration real quick. Actually, I'll just pull up this over here so you can see what it looks like when it's finished. And you can see now that as you fire, the shape of this player changes, and it really gives the illusion of it being in motion and being a living, breathing character. Okay, so hopefully those tips will help you out. Remember that all these can be applied in different ways depending on what your game is, and you don't have to include all of them. Even including 1 or 2 can be very helpful and help improve the overall experience of your game and the game feel. Okay, so I wish all of you good luck, and I can't wait to see what all of you come up with. All right, good luck, and I'll see you next time.